Section 2. Creating a user control character, ego. In order for the user to navigate in the scene, we need to create a first-person character controllable by them. A human-like character would be costly to program, adding only minimal value to our simulation since the navigation will be first-person. Thus, we resort to using an invisible game object as our user control character to which we attach a camera. We conventionally call the game object of our user character ego. The ego game object contains a capsule collider and a rigid body as components. In the collider, we set material attribute, which is responsible for the physics of the game object's collisions, to be a physics material called default material, defined by us and to be discussed in later sections. The use gravity option of ego's rigid body component is false because ego never falls down. Freeze rotation constraints are all true, so that ego is not being overturned when colliding with the virtual lab's furniture, but from freeze position constraints only y is true, since we want ego to be able to move along the x and z axis, that is, the horizontal plane. The rest of the options for ego's rigid bodied component are the default ones. Ego game object has a child, that of camera, that is, the game object whose sole component is the main and only camera of the game. Take notice that camera game objects tag in the inspector is set to main camera, which is of use for its handling through the script as we shall see in later sections. Section 2.1. Creating the ego controller script. How the user controls the movement of ego inside the virtual lab scene is the one part of the user interface of the game. The other part of the UI is the interaction of the user with the various objects and instruments in the lab, which we will deal with in the next section. Section 2.1.1. Ego's movement. Regarding the first part of the UI, in order to program the user controls of ego, we first need to decide how the latter's movement inside the virtual lab scene is going to be made. A practical solution is to adopt the most popular control method in first-person computer games, that is, the WASD arrow keys. In particular, we set ego to move, left with A or left arrow key, right with D or right arrow key, forward with W or up arrow key, and backward with S or down arrow key. We are now ready to create our first monobehavior script, namely egocontroller.cs, which we attach to ego game object. In the ego controller monobehavior class, we first create two global float variables, move vertically and move horizontally, capturing respectively the key being pressed on the horizontal axis left-right or the vertical axis forward-backward. We also create two other global float variables defining the speed we want the ego character to move along those axes, linear vertical speed and linear horizontal speed. Those variables should be public so that we can set their values in Unity Editor for convenience. In addition to those, we define a global variable RB of rigid body type. RB is said to be a reference to ego's rigid body in the start function. Then, in the update function, we add the following block of code. Move vertically variable reads the input for vertical move from the keyboard which corresponds to the aforementioned keys for forward-backward move. Particularly, for a forward move, move vertically gets a positive load value, while for a backward move vertically gets a negative load value. If the value of move vertically is not zero, through the RB move position function, Ego's rigid body is being moved along its relative z-axis by a distance of linear vertical speed times move vertically times time delta time, where time delta time is the amount of time in seconds that passed since the last frame was drawn. Then move vertically becomes zero again, otherwise Ego would keep moving on its relative z-axis even if the user is not pressing the respective keys anymore. Move horizontally and linear horizontal speed variables control Ego's rigid body movement on the latter's relative x-axis in a similar fashion. Now let's test our code. In the inspector for Ego character, in the Ego controller script that we have attached to it, we set linear horizontal speed to be 5 and linear vertical speed to be 10. Now we press play and we see that if we press up arrow or down arrow, we get Ego character to move on the vertical axis. And if we press left arrow or right arrow, we get Ego character to move on the horizontal axis.